Earth's magnetic field has weakened 20% in just 23 years. The magnetic North Pole is racing toward Siberia at 37 miles per year, faster than an immortal snail could ever chase you. And two major studies published in the last month have confirmed what scientists have been quietly whispering about for years. Magnetic pole shifts are directly linked to mass extinctions, and we're overdue for one by about 480,000 years. I'm going to show you the data they've been collecting, the acceleration that's happening right now, and why this could be the single greatest natural disaster humanity has ever faced, one we've never experienced in recorded history. Because when this flip completes, it won't just mess up your compass. It could shut down power grids across the planet, expose us to radiation levels that make air travel unsafe, and fundamentally break the navigation systems of millions of animals, including the ones we rely on for food. Let's start with what's actually happening right now. Pop quiz. Where is the North Pole? If you pointed to the top of the globe, you're wrong. The geographic North Pole, the point Earth spins around, never moves. But the magnetic North Pole? That thing is on a road trip. In 1831, it was deep inside Canada. By 1999, it was drifting at about 9 miles per year. Unusual but not alarming. But then something changed. Between 2000 and 2005, the speed doubled. By 2017, it was 240 miles away from where it should be. And as of 2021, it's moving at 37 miles per year, racing northwest towards Siberia. The British Geological Survey team had to start taking measurements more frequently just to keep up. That's how fast this is happening. But here's what should actually terrify you. The magnetic field strength is collapsing even faster than the poles are moving. In the year 2000, NASA reported Earth's magnetic field had weakened by 10% since 1850. Not great, but spread over 150 years, that's a slow decline. Then in 2010, the European Space Agency updated that number. We were down 15%, and the rate of loss had accelerated from 5% per century to 5% per decade. By 2020, another 5% gone. And after the latest acceleration detected in 2023, some scientists estimate we could be losing 5% every 5 years now. Let me put that in perspective. The first 10% of field strength took 150 years to lose. The next 10% took only 20 years. One researcher plotted the most likely curve based on this acceleration, and it shows that by the early 2030s, we'll hit 50% field strength, the point where our technological way of life becomes unsustainable. And by around 2040, we could hit full magnetic pole reversal. Now, before you think I'm just fear-mongering, let me show you what scientists are actually finding when they study past pole shifts. For decades, scientists argued about whether magnetic pole shifts actually cause extinctions. Some said yes, others said it was coincidence. That debate is over. A preprint study released just days ago analyzed the geological record and found a direct correlation between magnetic pole shifts and the greatest mass extinction events in Earth's history. Then, a couple weeks before that, another study was published in Geophysical Research Letters, one of the most prestigious journals in the field. Their conclusion? The combination of climate chaos and increased radiation during pole shifts presents a major problem for life on Earth. These aren't fringe scientists. These are the top researchers in geophysics, working with the best data we've ever had. And what they found is this. During a magnetic pole reversal, Earth doesn't just have 2 poles. It can have 4, 6, or even 8 poles simultaneously, all fighting each other for dominance. This creates a chaotic, fractured magnetic field that's up to 90% weaker than normal. And that weakness lasts for hundreds, sometimes thousands of years. So what actually happens when the field gets that weak? 2 things: radiation exposure and climate collapse. Earth's magnetic field is an invisible shield. It deflects most of the dangerous radiation from space, cosmic rays, solar protons, high-energy electrons, and funnels the rest toward the poles where almost nobody lives. But when the field weakens and fractures during a pole shift, that radiation doesn't get deflected anymore. It punches through, and the poles, the areas that normally absorb the radiation, can move to the equator, directing particle radiation at the most life-dense regions of the planet. Here's what that means practically. For the ozone layer, hundreds of studies confirm that solar protons, electrons, and cosmic rays destroy ozone molecules. More radiation equals more ozone loss equals more ultraviolet light reaching Earth's surface. UV light doesn't just give you sunburn. It damages DNA in plants, animals, and especially the microorganisms at the base of the food chain, plankton and chlorophyll producers in the ocean. For living creatures, the extra UV radiation and particle radiation increase cancer rates, cause cellular dysfunction, and trigger DNA mutations. This doesn't just affect humans, it affects everything. For air travel, planes already receive higher radiation doses at altitude. With a 90% weaker magnetic field, certain flight paths could become too dangerous without additional shielding, and we're already seeing a preview of this. There's a region over the South Atlantic Ocean called the South Atlantic Anomaly. It's an area where the magnetic field is already significantly weaker than the rest of the planet. Why? Because deep beneath that region, a portion of the magnetic field has already started flipping direction. Satellites passing over this area routinely shut down their electronics to avoid damage. The Hubble Space Telescope powers off its instruments every time it crosses the anomaly. Astronauts on the International Space Station report seeing bright flashes of light in their vision when they pass over it, caused by high-energy cosmic rays penetrating their eyeballs because the weakened field can't block them. This anomaly has been growing. It now covers a fifth of Earth's surface, and some scientists believe this could be an early sign that we're already in the beginning stages of a full magnetic reversal. But here's where it gets even weirder. The poles aren't the only thing shifting. The rotational axis, the imaginary line the Earth spins around, is also moving. And this one's entirely our fault. Since 2003, the axis has shifted 78 centimeters. That might not sound like much, but it's extremely unusual for such a rapid shift. The cause? Groundwater extraction. Between 1993 and 2010, humans pumped over 2,150 gigatons of water from deep underground reservoirs to the surface. That's enough water to raise global sea levels by 6 millimeters. When you move that much mass from deep underground to the surface, you change the Earth's moment of inertia, the same physics that makes a figure skater spin faster when they pull their arms in. We've redistributed Earth's mass unevenly, and it's caused the planet's rotational axis to drift. Scientists confirmed this by using radio telescopes to observe quasars, super bright objects in distant space. The quasars weren't where they should have been in the night sky. The Earth had literally tilted, and according to the research team, this drift is permanent and growing every year. So we've got magnetic poles racing toward Siberia, a magnetic field collapsing at an accelerating rate, and a rotational axis wobbling because we drained too much water from the ground. What happens when the flip actually completes? Let's be clear, a magnetic pole flip won't happen overnight. The chaos could last for centuries, but there will be critical moments when the field strength drops below a survivable threshold for modern civilization. Here's what scientists expect. Power grids fail. When the magnetic field gets weak enough, a large solar storm, something that happens regularly, will induce massive electrical currents in power lines and transformers. This is called a geomagnetically induced current, and it will fry infrastructure across entire continents. No electricity means no water treatment, no refrigeration, no food transport, no internet, No phones, no hospitals. One study estimated that a single large solar storm today could cost the U.S. economy $41.5 billion per day. That's with our current magnetic field strength. Imagine the damage with a field at 10% strength. Animal navigation collapses. Birds, whales, dolphins, sharks, sea turtles, and many fish species use Earth's magnetic field to navigate during migration, find food, and locate breeding grounds. Insects use it to regulate hibernation and reproduction cycles. Even plants rely on the magnetic field for germination and growth. When the field fractures into multiple chaotic poles, these navigation systems break. Migration routes fail. Reproduction zones become inaccessible. Ecosystems collapse. Climate chaos accelerates. The extra cosmic rays don't just increase radiation exposure, they amplify weather extremes. More heat, more cold, more wind, more lightning, more floods, more droughts. Everything gets pushed to the maximum. And remember, this isn't speculation. This has happened before, multiple times. And every time it did, life on Earth took a beating. So what do we do about this? The uncomfortable truth is, we can't stop a magnetic pole shift. This is a natural process driven by churning liquid iron in Earth's outer core, 1,800 miles beneath our feet. We have no way to control it, but we can prepare. The European Space Agency's Swarm satellite mission is currently collecting the most detailed data ever on Earth's magnetic field. They're trying to build better models to predict when and how the flip will happen. We can harden electrical grids against geomagnetic storms. We can design satellites with better radiation shielding. We can develop contingency plans for food production if animal populations collapse. But here's the thing, none of that is happening at scale. Because for most people, this feels distant, abstract, something that might happen in the future. Except it's not in the future. It's happening right now. The field is weakening. The poles are racing. The anomalies are growing. And two major studies just confirmed what researchers have been warning about for years. Pole shifts are extinction events. We're long overdue for one by about 480,000 years. The last one happened 780,000 years ago. The average time between flips is 300,000 years. We're not just overdue, we're extremely overdue. And all the data suggests it's already begun. So the next time someone asks you where the North Pole is, you can tell them it's racing toward Siberia at 37 miles per year, and it might not be there much longer. If this video made you rethink how fragile our planet actually is, share it with someone who still thinks 2040 is far away. Because it's not.